So, who stole stuff from the pantry? Hi guys, my name is OG. Welcome to our show Probotix. And in this show, we're going to be learning all about robots, and we're practically looking for every excuse to build one. Joking, right? In learning about robots, there are certain things you have to understand when you're going to build one. Robots consist primarily of a chassis, the electronics, and the motors. The motors usually attach to the wheels, which the motors drive. The chassis houses the whole robot structure and holds the whole electronics and motors in place. When you're building robots for indoors, a plastic material based chassis could be appropriate for indoor applications. But if you're going to be building an outdoor application, you need a stronger chassis. And usually you want to consider using a stronger material like metal. Next up, electronics. Electronics for your robot will usually comprise of computers, sensors, and motor drivers. Computers are the brains and are central in making of your robot, and it usually helps your robot make decisions. Popular computers that you can use to program your robot includes the Arduino. The Arduino is a very popular microcontroller application development platform that you can use to give your robot functionalities. Use C++ programming language to be able to write instructions that you can give your robot to do certain things. Another computer platform you can choose is the Raspberry Pi. The Raspberry Pi is a single board computer which is the size of an ATM card, and it actually has a lot of functionality that allows you to be able to write programs with Python programming language and to be able to give your robot functionalities. In looking at robots, a robot will usually have one or more motors in them, and that means that they will usually require a motor driver, and a motor driver usually has enough power to correctly drive a motor. Finally, under electronics, a robot may have sensors. Just like humans have sensors to be able to sense their environment, a robot usually will use sensors to be able to sense their environment, and based on those things that they have sensed, they can use those things to make decisions. Let's not forget, a robot will require batteries to be able to power it to work correctly. That was a lot to take in, right? Rather than source all your robot parts from different places, which will take a lot of time, you can readily jumpstart your robot building process by buying a robot chassis kit online, which is readily available on all your online local stores. This kit will save you a lot of time, and the kit is not even expensive. Setting up the robot chassis kit is very easy and very straightforward. I start by attaching the encoder wheel to the DC gearhead motor drives, and using fasteners I attached the motors to the chassis, and I used some screws to secure the motors on the chassis. Next, I repeat the whole process for the other 3 motors. You also want to do well to check that all the fasteners and the screws are properly secure on the motors and the chassis so as to prevent wobbling or shaking while your robot is moving. I should quickly say here that robot parts and the electronics are not cheap. That's right. But it's really an investment that is worth it. Let me tell you something. Corporations and countries all over the world are investing in robot programs all over the world. According to International Federation of Robotics, 2.7 million robots are in operation in manufacturing organizations around the world. Think about it. Next, I'm going to show you top 5 countries with the highest robot installation in their manufacturing industries. Number 1, China. Number 2, Japan. Number 3, the United States. Number 4, Korea. Okay, South Korea. Number 5, Germany. Another very important stat that is used by the International Federation of Robotics is robot density. Robot density is usually a stat that is usually used to measure the number of robots per 10,000 workers in a manufacturing industry. So next, I'm going to show you top 5 countries that have the highest robot density in the world. You ready? Number 1 country with the highest density is Singapore. Singapore has 918 robots per 10,000 workers. That means that for every 10,000 workers in the manufacturing industry, Singapore has 918 robots in that industry. Number 2, South Korea. South Korea has 855. Number 3, Japan. Japan has 364. Number 4, Germany. Germany has 346. And number 5, Sweden. Sweden has 277. Robots are so popular that it has even affected pop culture. What I'm doing in this design is that I get to use separate power supplies for both the Arduino and the motors. It's usually best practice and a good design when you're designing your robot to use different power supplies for both your computer and your motors. For this design, the full bill of material includes an Arduino Nano, two L298N motor driver module, 4 DC motors, and 4 diodes, 4 3.7 volt lithium ion rechargeable batteries, 4 1.5 volt AA batteries. That is what is included for this design. The circuit diagram shows a connection, which I have done already, which I will just explain in a bit. For explanation of this circuit, I'm going to start with explaining the power supply for the Arduino Nano. The Arduino Nano uses 4 1.5 volt AA batteries, which totals 6 volts, and supplies this to the voltage input pin Vin of the Arduino Nano. The Arduino Nano has an internal voltage regulator which steps down to 6 volts to 5 volts, which it uses to supply to its system. The Arduino Nano controls the 4 DC motors using data and control signals through the L298N motor drivers, which you can see right here. You can see the connection from the Arduino Nano connecting to the L298N modules, which you can see the data lines and the control signals, which connects to the motor drivers, the L298N motor drivers. The L298N motor driver module can control a total of 2 DC motors independently. And for our design, we're using 2 L298N modules to control a total of 4 motors, which you can see here. You can see motor 1, motor 2, motor 3, motor 4. Each of the motor driver modules have 2 3.7 volt batteries, which is a total of 7.4 volt for each of the driver modules. The datasheet for the L298N motor driver module specifies a total of 5 volts to 35 volts as the input, and we are using 7.4 volt in total, which makes us well within the design range. The different motors that are connected to the L298N motor driver allows for independent movement of each of the motors, and each of these motors have a diode that is attached to them, and these diodes are placed across the DC motors for noise level control, which is generally removing back EMF generated by the inductors within the DC motors. You can actually use different designs when you're going to be designing your robot. You can use a front wheel drive system or a rear wheel drive system, or you can make all the drive system, or you can do a 4-wheel drive system where all the motors are powering the robot wheels and they're actually moving independently depending on your design. But in this design, I'm actually doing the 4-wheel drive system. With a 4-wheel drive system, you can achieve complex maneuvering. Like I can do a donut left that allows the robot to do a spinning left, and I can do a donut right that allows the robot to do a spinning right. But in the case of a 2-wheel drive system, the robot is either going to be powered by the 2 front wheels or powered by the back wheels. Usually it's the front wheels, where the front wheels are usually the drivers and the back wheels are followers. But in my case, I've designed a 4-wheel drive system that allow all the wheels to move independently and in a coordinated way. So we still not found our thief yet. I promise that in the next episode we'll get him, won't we? So I hope you enjoyed the show. That'll be all for now, and I'll see you in the next episode. Bye.